Hi, I'm Alex and I welcome you to my JavaScript and TypeScript Quick Start course. All the code presented in this video will be available for you on my GitHub page. The link is in the description. Once you get to this GitHub page, you have the option to go right here to the green button and to simply download everything as a zip, or if you are using GitHub, you can simply clone this repository. In order to follow the course, you will need three tools which should already be available on your system. First of all, I'm talking about a recent version of NodeJs. If you don't already have it installed, you can go to nodejs.org and then to the download page and follow the steps appropriate for your specific system. A more recent version of Node.js is preferred. You will also need a code editor. I see no reason to use other code editor than Visual Studio Code. It works perfectly with JavaScript and with TypeScript. If you don't have it already installed on your system, you can go to its official website at the download section and download the right executable for your system. And also you will need a web browser. If you see this video, I'm sure that you already have a web browser installed, but I will advise you to use a Chromium-based web browser. This being said, also the course structure is available as a video outline for you. If a certain topic is of more interest for you, you can go directly to that topic. The course has two parts, first of all JavaScript and then TypeScript. You can follow along as you prefer. Let's get started. Okay, time to write our very first JavaScript program. Let's get started. In order to write a JavaScript program, you need to create first of all a JavaScript file. I will create one right here in this basic examples folder, and I will call this hello.js. This will be a hello world program. And first of all, we want simply to print something to the console, nothing more complicated than that. Well, in order to do this, we first of all have to invoke the console object. Then inside or on this object, we have a method or a function called log, and this function has some arguments. In our case, I will say right here, hello world. And even this is a trivial example, let's identify what we have right here. So first of all, if I hover with my mouse over this, you will see that this is a console of type console, and this is something provided by the runtime. The runtime being Node.js or the browser. Then on this object or on this functionality provided by the runtime, we have the option to call a function or a method, and we can call it using the dot. So I'm pressing the dot, and then I have the functionality provided by this console object. This is a function, and the function will support one or more arguments. In our case, we are passing one argument with the hello world text. Now let's run this file, and in this case we have two ways in which we can run it. First of all, we can run it using the Node.js runtime, which you should have installed. So I can say right here node, and then I need to pass the path to my program. In my case, this program is located inside the basic examples folder. So right now the terminal inside VS Code is in this JSTS course folder, but I need to pass the relative path to this basic examples folder first. I will press the first character of the name, which is 1, and then if I press tab, I will see the name of the folder, and inside this folder I have the file hello.js. Again, I can press the first character and then tab. I click on enter and I see my message, and my program is running just fine. This was one way in which I can run this JavaScript file. Another way would be to put it inside a HTML file and run it inside a browser. I will do also this, so I will create a new file and I will call this index.html, and inside this index.html, using VS Code, I can press the exclamation mark, and I will see an emmet abbreviation. This will give me a simple template of a web page, and right here, maybe inside the head entry or anywhere, I will add a script tag. I will also close it so I don't forget to do this, and this script should have a source, and the source of this script is it's hello.js. Now what we have to do, we simply have to open this HTML document inside a web browser. For this I will simply open the containing folder of this file, and I will open this with a web browser. In my case I will open it with Brave since it is based on Chromium. And I have opened this and I don't see anything. Well, was my file run or not? I can see this if I right click anywhere inside the web page and I click inspect and I open the developer tools. And right here I have the entry called console. If I look at this entry called console, well, I see my message. So also in this case I was able to run my JavaScript file. Before moving on with the language features, let's talk a little about the differences between running a JavaScript program inside a browser versus Node.js. I'm inside the developer tools inside a Chrome browser, and as you can see here inside the console view, I have like something resembling a cursor. Well, inside this cursor, I can have access to everything that the browser provides. In our case, I can invoke, for example, I can say right here window, and if I write window and then I press enter, I will see a print of the window object or functionality provided by the browser. If I open this, if I expand this view, you will see a list of all the methods or actions that I can take inside a window using JavaScript. And as you can see, one of these actions is alert. Let's write a program that will simply invoke this alert function inside our project. So right here I will create a new folder to keep things organized, and I will, inside these basic examples, I will call this browser, and inside this browser I will create a new file. I will call this again maybe alert.js, and inside this alert.js I have the option again to access the window functionality from the browser. Right here I have the option to call the alert function, and again let's say something to the user. Again I will say hello world, exclamation mark, very important. Now let's run this file. Again, let's reference it inside a index.html file. I will simply copy this index.html and I will put it inside this browser because I'm lazy, and now I will simply rename this to alert.js. And let's run this file. Again, I will go to my file explorer and I will open again this inside my browser, and as you can see, as soon as I'm opening this, I see a alert with this hello world message. Well, now what do you think will happen if, for example, I will try to run this alert.js with Node.js? Let's see. If you think it won't work, you are very right, but let's be clear about this. So I will call again node and then the reference to the path to our file, basic examples, now inside the browser folder, and right here we have the alert.js function. If I will try to run this, I will get a reference error because it will tell me, hey, I don't know what window you are talking about. And this is a very important thing that you need to understand if you want to prevent or understand the future errors that you will receive when you will want to run some JavaScript code. So some JavaScript functions are common to both the browser and the Node.js environment. For example, the console object, but many other objects, while other JavaScript functions or features are only available inside the browser, like for example the window object. Let's also see an example dedicated to Node.js. So I'll create yet another folder. I will call this node, and right here I will create a new file. I will call this createfile.js, and I will paste right here a bunch of code. You don't have to understand too much about it. As I said, you don't have to understand too much about this. You simply need to maybe take it from the reference or from the screen you are seeing right now. What this file will do will simply create a new TypeScript file inside my computer with the text hello world. And creating files can only be done by the Node.js environment. There's no option, first of all, for security reasons, that a browser or a website can simply create random files on your computer. This is not possible. But if I will run this program, so let me clear this again, and I want to run this time node, basic examples, I want to run this node, createfile.js. If I will run this, you'll see a new file will appear inside my computer, a hello.txt file containing the hello world text. And as I said, this is only able to be run inside the Node.js environment. If I will try to reference this file inside an HTML file and open it inside the browser, you can try to do this if you want, but be sure this won't work. Let's now talk about data types in JavaScript, and we have a few primitive data types in JavaScript. Primitive means simple, and then we also have a non-primitive data type. But let's talk first about the primitive data types. We are talking about strings, first of all, which are simply a representation of text. Then we have numbers, which can be integers or float numbers or so on. They are all numbers. Then we have big integer, which are big numbers. We have Boolean values, which can be true or false. Then we have some more interesting values like the undefined and null. Observe this, I'm saying right here, let is undefined is or equals undefined. And undefined represents a variable with no value assigned. So currently I said that this is a variable. In the next lecture we will talk about variables, but right now I said that this is undefined, I said it to be undefined. If I will just leave it like this with no assignment, it will still be undefined. So it's something like an address pointing to nowhere. Then we have null, which represents no value, and symbol, which is a unique immutable value. In my experience, in 10 years of writing JavaScript code, I never used symbols. Now, don't expect to understand just right away how these data types work. Well, when you will start to use them inside your different programs, small or even bigger programs, you will understand better how they work. And in the end, we also have objects. Objects are simply collections of key value pairs. For example, we have an object right here called employee. This is the name of the reference. And this employee has 3 fields. These are the fields: the name field, the position field, and then the salary field. These objects are a more complex data type, which will represent more complex data. And in the end of this lecture, let's also talk about a very important operator, the type of operator. So let me write a bunch of code and then explain it. So we have the type of operator, which will indicate the type of a variable. So when you will want to know exactly what kind of data you are working on, you can use the type of operator. And let me run this simple code right here and see what JavaScript will tell us about the type of these variables. So I will execute this code. And you can see that this type of hello is string, type of 3.14 is number, and so on. The type of null is object. This is very interesting, and it's a key point to have in mind. So when you will try to find the type of null is object. The type of symbol is symbol, and then the type of a more complex object is again the object. Let's now talk quickly about strings, a very important data type in JavaScript, and we can define strings in multiple ways. First of all, we can define them using quotes. We can define them both with single quotes or with double quotes. Then we have the technique of string concatenation. This means that we can link different strings together using the plus sign. And in the end, we also have a template literal or a template string, which we can define first of all using the backticks. This is the name of this character on the top left of the keyboard usually. And here we can have like insert variables inside this string. For example, if I will simply print this to the console, so here I'll say console, I will print this to the console and I will execute this code. You will see I will see in the place of these variables, I will see their values. The first name in our case is John, the last name in our case is Smith. If I will print, for example, the full name, you will see something interesting. You will see John Smith without any spaces. If I will want to add spaces right here, I will need to also provide the space character. If I will execute this one more time, I will see the right name like this. We also can have prints or strings with line breaks. If, for example, I will copy this and I will call this print with line break, I can use the sequence of characters backslash and then n, and if I will print this to the console, I will see the line break right here after I put it inside the string. So the backslash n indicates a line break inside our string. Also, we can use these backticks to define a long text. If I will put right here a long text, you can see that this is a long text, and I can even use any character right here inside this template literal or with these backticks. And if I will create a line break inside this text and I will simply print it to the console, let me print this long text. Again, if I will execute this, I will see the line break right here. In the end, I want to also point out that, for example, I will create a new constant called toUpperCase, and I can take a string, and if I will use the dot notation after the string, I will see a list of all the functionality that this string has. For example, strings have a length, and this is the length of characters of the string, and they have a lot of methods. For example, if I want to see the uppercase of a string, I can call toUpperCase. And I need to call this as a function. We will talk about functions in the next lecture, but again, if I will print this, you can make an idea about what will happen. I will see the uppercase value of this string. Let me see. Yes, I see the uppercase value. Again, this is an introduction to strings. You will use them most often inside your JavaScript programming, and with time you will understand better how they work. In JavaScript, we have three types of variables. We can declare a variable using the var keyword or the let keyword or the const keyword. In the early versions of JavaScript, we declared a variable using the var keyword, but now maybe 99% of the time you won't have to use var anymore. You will use either let or const. And first of all, let's answer the question, why do we even need to declare a variable? So this is like a variable declaration. On the left, we have the variable name. In our case, this is A, this is B, this is employee. On the right side of the declaration, we have the variable value. Now, this on the right side, there's a piece of information that we can reuse throughout the runtime of our program. So every time we will want to access this piece of information from the program memory, we will simply use its value name or the reference or its address in the memory. Now let's talk about the differences between let and const. Let simply is a kind of variable that can be reassigned. So I have this b right here, which is a string. Lower down the line, I can simply call b to be maybe a number. I can assign it to 5 and everything will work as it should. But for example, for the employee, if I want to say here employee, and I will simply assign it another name, I will say right here Mary. What do you think? This will work or will not work? Let's execute this program and see what happens. So let me run it with Node.js. Well, I will get a type error. It will tell me that, hey, you are trying to make an assignment to a constant variable. So this won't work. Let me simply copy this message and add it as a code comment right here. So we know that this won't work. However, there's a key difference between this operation in which we are trying to reassign the whole address or value of the reference, but we can simply call employee.name and we can set this to Mary. And at this point, we are not changing the value of the reference. We are simply changing the value of a field of our reference. So this is perfectly legal. Let's say it like this. If I will execute this code right now, I won't get any errors. So everything is as it should. Maybe you want to simply be able to declare objects and never be able to change them or reassign them again. These are usually called read-only or final objects, and this is a feature missing in JavaScript. It is a simple feature if in TypeScript. We will learn about TypeScript later in this course, but still there's a solution in JavaScript if we want to create an object that can't be changed. And we can do this with the object.freeze method. So at this point, if I will hover with my mouse right now, you will see that VS Code will tell me that, hey, this object is read only. Well, I can still access the fields of this object and I can say this locked employee name and I can still give it another value, like for example, Mary. But when I will print this locked employee again, let's print his name and see what we get. We will still get John. So this object.freeze will not prevent us, so this won't throw a runtime error. However, this will have no effect. Let's now talk about arrays in JavaScript, and they are simply a collection of values. This is the syntax in which we can declare an array. This is the one with 2 square parentheses. And now if I will access this numbers array, if I will press the dot notation, I have a lot of options or a lot of functionality built into this array. First of all, we need to add something to the array. So we can add elements to the array with the push method, or we can simply add them at initialization time like this, but I will simply push an element to this array. I will push the number 1, and now let's print this first element of our array. If I want to access it, I need to access it with the square parentheses and then the index. So if I want to get the first element of the array, I need to select the 0 element. So in programming, always arrays will start at index 0. This is the first element of the array. If, for example, I will try to access an element which is not present in the array, for example, I will want to access the element at index 1, which currently doesn't exist. Let's see what happens. I will execute this program. I will first see the first element at index 0, and then if I will try to access something that doesn't exist, I will receive undefined. Alright, let's push again other elements to our array. Let's say that I want to push multiple numbers, and there's an important catch right here. I will say right here numbers, push, and then I want to push other numbers, like for example 1, 2, 3, like this, or I can push them like this. And what do you think will happen? They will end up in the right place? Let's find out. If again I will at this point print these numbers, let me print these numbers and let's see what happens again. Alright, and this is now our array. We have the first element, but then in the second element something interesting happens. We have a second element pointing to a different array. So this is not certainly alright. In JavaScript we have something called a destructuring operator or the spread operator. Or let's first of all remove this last element of our array, and we can remove this last element with the pop method. So here I will say numbers.pop, and this pop method will remove the last element from our array. I will call this pop. Let's print the array again, and this time we are at 1. That's great. And let's now push again our numbers like this. Of course I can simply add these numbers like this and everything will be alright, but let's learn also about the spread operator. And this spread operator will transform an array or a collection of elements. It will simply destructure them into 1 and 2 or 3. Let's now see how our array looks like, or maybe 2, 3, 4 to have some logic inside our program. Alright, let's run the program again, and this time our array looks alright. This was just an introduction to arrays, because arrays are much more complex, but I let you discover this complexity when you will build some projects using arrays. Let's now talk about loops in JavaScript, and with loops we can repeat a certain action until a certain condition is met. And the most simple loop, let's say it's called a for loop inside JavaScript, and the for loop has two parts. First of all we have the condition, and then we have the action that the loop will take. For the condition, you can see that we start with an index, which we can define at 0 or at any number value. Then we have a condition, and the condition that will simply be checked for each entry inside the loop, and then we have the increment part. For this particular set of code, let's see what we get. So I will execute this. So we can see a print of each index value until the condition is met. Our condition was that the index should be smaller than 5. Once it is 4 and then we are simply incrementing it, this condition is not met anymore and the for loop is exited. There's another loop in JavaScript called a while true loop. This is the one, and the while true loop is a little easy to understand because we only have one condition, and that condition can be changed outside the while true. For example, this code will do exactly the same, but we are initializing the variable outside the loop. Let's run this code again, and we will see the exact same thing. This while true loop is really not used so much. Maybe it is safer to use this for loop because we are initializing everything inside the for loop, while right here this condition is initialized outside the loop. And in the end we have a particular case of the for loop. It's called a for loop with an array, and this time we can iterate over an array. And in my opinion, this is the most easy to understand. We simply have an array of values and we can simply invoke an action for each value of that array. Let's also run this code, and we are iterating right here over the array, and we are taking an action for each entry inside the array. This is also called a for of loop. If we would look at the code that we wrote until now inside this tutorial, we would just open a sample piece of code right here. Well, we can take a quick look, but we can't just say what exactly we did. We look at some variable names, at some console logs, but what does it exactly this code does before we run it? So we can't really say. Well, this is the point where we start to talk about functions. So functions are a very important concept in programming and in JavaScript, of course. Well, functions are a reusable, and this is the very important point, reusable piece of code designed to perform a specific task. So let's see an example. I will have a new file right here, and let's see an example, a simple dump example. This function get greet, and I will add another function to understand a little some nuances right here. So first of all, functions are declared using the function keyword. So this is a reserved keyword in JavaScript. We use it to declare a function. After we use the function keyword, we have the function name, and we use this name in order to invoke or reference the function. Then functions have a list of arguments. In our case, these both functions have a argument, a simple argument, a name, but of course functions can have no arguments, or they can have a lot of arguments. There's no limit on the number of arguments a function should have. But just as a good practice, a function shouldn't have more than 3 or 4 arguments. Then we have the function implementation, and in our case we simply are returning a string. So this is the function body, which will actually contain the code that will be invoked when the function will be invoked. And there's a key difference between these two functions, and here we are talking about the return type. Functions can return something or not. If I will hover with my mouse over this example, you will see that we have like a colon right here, and then we have the return type of this function. In our case, we are returning a string, and we are specifying the return of a function using the return keyword. If we look at the other function, you'll see that at return type we are seeing void, because this function doesn't return anything. Now let's use these functions and to understand better what they are. So here I'll say const greet is get greet of some name, for example John, like this. If I will hover with my mouse over this, you'll see this will be of type string. But again, let me invoke again the function, and this time I will say greet2, and I will simply use the other function. And if I will hover with my mouse over this, you will see now this will be of type void or undefined. If I will try to print this greet2 variable, I will see undefined, because this greet function doesn't return anything, it just takes an action. Now, how can we invoke different functions? We simply need to use their name. For example, I will say get greet. I could simply save my file right here and I will have no compilation errors, but the function won't be executed. This is a common mistake. You don't know why your code is not executed, and then you see you forgot to actually invoke the function with the 2 parentheses. You will see JavaScript won't enforce us to provide an argument for the function, even if the function requires one. And let's save this to a constant and see what we get. So here I'll say const result is our get greet, and let's provide no arguments and see what we get. And if I will execute this code, I will see no result. If I will try to print this result and invoke this again, you'll see now that undefined is passed to the function, because we didn't actually pass anything or something defined. But if I will pass an argument right here, like for example John, and I will invoke this code again, this time the argument will be passed. So functions are great at reusing code. For example, we have this getGreet function, which will simply return a string, but we can invoke this code no matter how many times we need it. And maybe sometimes we will want to simply organize our code, we don't want to reuse it, but we will use functions in order to reduce the scope of variables. For example, I will create a new function. I've named this function invoke, and I can say right here, I will save a const name and I will save this to John. Now the very important point about this name is that it only exists inside this function, and this is a very important good practice for JavaScript code. We should wrap all our code inside functions to make sure that maybe we don't have any collisions with other constants or variables inside our code. I can say this invoke function and then I can call maybe the greet function with this name, and if I want to call this function I can simply call it downstairs. I will call invoke and then with the two parentheses, and if I execute this code everything will work as it should. With newer versions of JavaScript there's another way in which we can declare functions. This is the ES6 way of declaring functions. We can say const add and then we can simply use this syntax, which in my opinion is not as clear as the function syntax, even if it is a little shorter. Again, I can invoke this add function, just I would invoke with other functions and everything would work as it should. And in the end, let's also talk about functions without name. So for example, before we talked about arrays. Let me create a simple array. This is a simple array with 3 numbers. Now arrays will let us, for example, have a lot of built-in functionality inside them. Or one of them is for example, the for each method or other methods like the map method, but let's just use the for each method. If I will hover with my mouse over it, you will see that this function, the for each function built in into arrays, requires a callback function. So I will simply, if I will invoke this, I can pass a function to this for each function as argument, and I can simply pass it like this, and this for each will have an argument, and inside this argument I can do actions with this argument. For example, I can say console log my argument. And this implementation of a function, it is a function, it has a argument and an implementation, but it has no name. And this is called a anonymous function because we only use it once inside this implementation. If I will run this code, again, I will see this for each implementation run just fine. So these anonymous functions are a little more hard to understand, especially if you have never worked with code before. Just have patience, and with time you will understand better how these functions work. Well, enough theory for the moment. Let's take a break from enlisting lots of features of JavaScript, and let's build 2 small projects, or 1 small project, but 1 version for Node.js and 1 version for the browser. We will build a simple dump application, a hello name application. How it will work? Well, inside the Node version, if I will execute this program, we will simply be asked inside the command line interface, who do we want to greet, and I will give a list of names, like for example, John, Mary, and Bill. And if I press enter, I will see 3 hi and then the names which I put. The same kind of application, we will also build it inside the browser. We will have a simple form, a text form, in which I will enter some names, again, John, Mary, Bill, and if I press this greet button, I will see 3 hi messages. Let's implement this and practice a little what we learned until this point. Let's now implement our greet program, first of all for Node.js. So our objective for now is to first of all read the command line interface or read from the command line interface. For this we will need a Node.js built-in functionality called readLine. So first of all, I will import or use this functionality. I can use it using the require function. This is a built-in function from Node.js. And we are saying to Node.js, hey, I want to use this built-in functionality inside yourself. When we want to, first of all, read from the read line. Then we need to create an interface from this read line. I will create an interface in which I need to specify an input and then an output. And with this RL object, we are ready to start to implement our program. This RL project function has a function called question, in which we can do exactly what we want. First of all, we can say a message, like for example, who do you want to greet? And then we can pass a callback, just as we did before, an anonymous function that will contain our response. So this is our function, and our function will receive some arguments. In our case, our arguments are exactly what we are entering into the command line. Let's see this. So inside the implementation of this callback function, I will simply print what we want. First of all, what we have. So I will say args, and basically we are done, mostly done. And at this point, if I will simply run this program, well, we are getting the message that we put right here, and now we can simply input our code or who we want to greet. Let's say we want to greet John, and things are all right and not. If I will press enter right now, I will see this John printed right here, but the program won't end. This is one problem. The other problem would be that we would want a new line inside this implementation. So first of all, in order to end the program, we can simply call this, first of all, RL object, and then we want to close this command line interface. Right here, we would want a space like this, and maybe a new line. We can add a new line, if you remember from the string lecture, with a \n. If I want to stop this program, I can stop it with command or control C. Let me clear this and run this again. Now we see the cursor on a new line. I can say right here I want to greet John, and I see back the response, and then the program ends. And at this point I can simply say hi and then our arguments. Hi John. Let's see if this basic implementation works. Yes, our basic implementation works, but the program could still use some refinement. Let's say we want to greet multiple persons separated by space. So let's say right here, let's ask who do you want to greet? Let's add the question mark, and let's just say right here we want separated by space. And now we want to somehow parse all the arguments that we will pass to our function. If, for example, I will say right here, maybe I want to greet both John and Mary and maybe Bill. I want to see as output then hi John and then hi Mary and then hi Bill. Let's implement also this. First of all, what we need to do, we need a way in which we can split our arguments based on the space character. And in order to make the code really clear, let's add this, or let's specify this code into a separate function. So here I'll say function split arguments. I will call it like this. What this function will receive some arguments. And inside this implementation, we can simply use a built-in function into strings. So here I'll say const splitted arguments. We want to call args, and we want to call the split method. But as you can see inside the VS Code, I have no content assist because these arguments are of type any. So VS Code and the compiler doesn't know anything about our arguments. This is a point in which or where TypeScript will be very useful. In the second part of this tutorial, we will talk about TypeScript. But until then, we can also somehow point VS Code and the compiler to the right direction using some basic code comments. So here I will say I will add a slash and then 2 stars like this, and then I will press on enter, and I will have this comment. If it doesn't appear to you, you can simply say right here or specify at param and then our arguments. And let's just say to VS Code that this is a string. And now, if I will hover with my mouse over this, you will see that VS Code knows that this is a string. And now, when I want to simply split our arguments, if I press the dot and then the control space, I will see all the methods from the string. That's great. And as I said, we want to call the split function, and we want to split our arguments based on the space argument. At this point, we can simply return our splitted arguments. And if I save this, now we have some strong types to our function. And strong types are always very good because they help you to prevent all kinds of nasty errors. We have arguments which are of type string, and then we have a type of string arguments like this. If, for example, I wouldn't have everything right here, if I add a star, then we simply wouldn't have any typing at all. Let me save this, and now let's use this different function inside our implementation. So instead of saying console log right here, we first of all split our arguments. So I'll say const arg splitted, and we want to split our arguments. And then we can simply call a for each inside this args splitted. So we have a for each function, which again receives a element. In our case is a simple a name, and we want to say hello name. So I will move this console log inside this for each function, and here I'll say hi and then our name. And basically we should be done. Let me save this and let's run the program again. Let me clear this and run it again. Who do we want to greet? We want to greet John, Mary and Bill. And this time we see what we wanted. We see hi John, hi Mary, hi Bill. Let's implement the same thing, but this time inside a web page. Let's do this in the next lecture. Let's now implement the same kind of application, but inside a web browser. Let's get started. First of all, we need a HTML page. Let me create one. I'll call this one index.html. And right here in VS Code, I will press the exclamation mark and I will access this Emmet abbreviation, a basic HTML document. First of all, let's add a simple button that will invoke an action from JavaScript. Let's call this button greet, and let's say that we want first of all a action to be taken from JavaScript when we press this button. In order to take an action, we have the option on click, and this on click should receive a JavaScript function. So I will give it a name. Okay, greet names like this, and this is a function, and of course we need somehow to have this function. I could implement it right here, but I want to keep my JavaScript code separated. For this I will create a new file. I will call this greet.js, and let's implement this function right here. And first of all, let's just print something to the console to make sure that the function is properly invoked. I will add a console log click, and this is our function. Now all we need to do is to import or to reference this greet.js file into our index.html. And we can simply add at the end maybe a script with the source greet.js. And let's see if at this point our application is working. I will open this inside my file explorer, and now I will double click this to open it inside my browser. Alright, we can see the button. Let me inspect this and see the developer tools inside the console. If I will click the button, yes, I can see the click message. I can click it multiple times and I will see multiple times our message. So our JavaScript code is invoked. Now comes the hard part. We need somehow, first of all, a input inside the web page for the names. For this, I will simply add inside the body a new input, and this input will be of type text. We need an ID to be able to reference this input inside our JavaScript code. So the ID, let's call this names input, and maybe let's add a placeholder. So here I'll say enter names separated by space. Let me save this and let's see the page. Yes, we can see now the input. That's great. Maybe let me just add also a break like this. All right, now we see the button right here. And now let's create a div that will contain the text that will be rendered by JavaScript. So I will simply create a div entry right here. And this div only requires an ID. Let's call this greetings. Greetings like this. And now it's time for our JavaScript code. So first of all, what we want to read, when we click greet names, we want to read the values from this input. We can do this fairly simple. First of all, I will say right here const and our input. We need to read the input and we can take it from the document. Then we have the option get element by ID. We want to pass the ID of our input. In our case, the ID is names input like this. And we want to take the string value of this input like this. If I will hover with my mouse over it, you will see this is of type any, and this will be hard to work from now on. For this reason, I will simply add a type as a comment. Until we will work with TypeScript, we can add the types like this. I will say that, hey, this is of type string, and now it is a string, and now we have the option to extract the names. So here I'll say const names, and we can say input split, and we can split these inputs by the space like this. Now at this point we have the names. Let's see if the code is working until this point. Let me print out the names. This should be a string array. So I will say right here John, Bill and Mary. And if I press the greet button, all right, something is not working. Yes, I need to reload the page. All right, and we see we are extracting the right way the input that we are putting inside the web page. Now all we have to do is to somehow build some HTML documents, HTML elements inside the web page that will contain our data. For this, first of all, we need a reference to this greetings div. So just as we did before with the input, we will now create a reference to the greetings div. So here I'll say greetings div, and we again take it from the document. Document get element by ID. And this greetings div had this ID greetings. All right. Now let's clear, first of all, let's clear this greetings div. So I will say right here greetings div. The inner HTML, we will clear it first to start fresh, and let's set it to the empty string. And now we can use again a for each function inside the names array. So here I'll say names. We will call a for each function. Again, let's add a anonymous function. This is the simple anonymous function structure. Each element will receive the name, and with the name we can simply create a new paragraph. So here I'll say const paragraph. Again, we can create an element from the document, create an element of type P, which stands for paragraph, like this. And now we can save our paragraph. We can add our text content to be, let's use a special string, hi, and then our name, like this. And we can add this new paragraph to our greetings div. So I will call greetings div, append child and our paragraph. And basically we should be done. Let's see if this implementation works. So let me refresh the page and add again. And let's now look at the page. And yes, this time our application works. If I will only have one entry, I will only see one entry. This is the reason we were simply clearing the inner HTML of the greetings div on each call of this greetNames function. So you saw right now a little JavaScript practice inside the browser. We are almost 1 hour into this tutorial and it's time to talk about more serious things. And in this lecture we will talk about HTTP requests. I'm currently looking at some server code that will create a server inside Node.js. Well, you don't have to really understand too much about this code. We will use it in order to make some HTTP requests. And if you want to follow along, you can take the resources of this course into the HTTP folder. I will simply start this server.js. So I will cd into this folder and I will invoke this with node and then this server.js. And this server will start at the localhost address and it will use the port 3000. Very important, maybe when you will try to make this action, maybe the port 3000 won't be available on your system and right here you will see an error. If that's the case for you, you can simply try a different port and so on. For me it works, so I will leave it as it is. And this server serves two methods. One basic method is the get method, and we can invoke basic get requests. If I will simply copy this link and if I will go to a web browser and right here if I will paste this address, I should see a simple message, a hello world. By default, browsers will make a get request. If we want to make more complex HTTP requests, then we will have to use a request client, like Postman, like Insomnia, but since we are using VS Code, I usually like to use a VS Code extension called REST client. If you search for REST inside the extensions of VS Code, one of the first results will be this REST client extension. I highly recommend you to simply install this extension. And once you have this extension installed, you can create a new text file .http. So you can give it any name, but ending with .http. I already did this, and with this request, or with this file, we can make different requests. For example, I can send the same request as we did with the browser. I can send it from this file. I will send this request and I see the same response, hello world, but our server also supports a post request. And the post request can have something resembling a body in which we can specify a number of parameters. I will specify this parameter numbers2. Let's see what happens. I will send this request and I will receive back a response containing a random numbers field and then an array containing some random numbers. If you observe, these are two random numbers. If, for example, I will put right here 20 and I will send this request again, I will receive back 20 random integer numbers. So basically this is how this server works. I will send it a parameter and it will send me back a response based on my parameter. Now let's create or let's invoke the same server using JavaScript code. In the next lecture, we will invoke this server using the fetch request from Node.js, and then we will do the same from a web client. So the server is still running inside my terminal. Let's access it using JavaScript code, first of all in Node.js. But since the code is a little complex and we already know a thing or two about JavaScript, I won't type it along. I already did it. You can take it from the resources of this course, and let's get over the code. First of all, you will see something new, two new keywords from JavaScript inside this piece of code. We have the async and await keywords, and you can see this async keyword stays always next to the function keyword. So this is an asynchronous function. Well, we will talk in more detail about async and await in the next lecture. For the moment, let's understand how we can make a fetch request. First of all, we have the URL, which we take from the server. We have the URL. Then we can use the built-in method. This is built-in since more recent versions of Node.js. Maybe in Node.js 16 or 18, you can't use the fetch request or method, but now you can use it. And you can use the same method also inside the browser. So you can simply, if I want to make a get request, I can simply call the fetch method built into Node, which simply accepts the URL. Then we somehow need to extract the text from that response, and we can simply print it to the console. Let's invoke this function. I will simply invoke it downstairs right here. So I will call make get request as a function, and inside VS Code, since this terminal is already used, I will simply create a new terminal by pressing this plus button. And right here I will cd first of all into this server. Right here I will cd into the node project or folder, and right here I will invoke node and then this client.js. And yes, I see the hello world text response from the server. Let's also see how we can make a post request. And this other method, I'm making a post request with the same method, the fetch, then our URL, and then we can simply add a object containing some parameters to our request. Very important, we can specify a different method. The method is post. Then if we are making a post request, we can add some parameters or some information to that request for the server. If you remember, in our case, if we are making a post request, the server expects a numbers parameter. And I'm passing this numbers parameter right here as the body of the request, and I also need to somehow stringify this object. So this is an object, and this JSON.stringify code will transform that object into a string that the fetch method and the server can understand. Now we will receive a response again with the await async syntax. As I said, we will learn in the next lecture about it. I'm parsing the response with the JSON method, and then I'm printing the response. Let's see what we get. So I will paste right here, instead of a post request, instead of the get request, I will invoke this post request. Let me invoke this code again. And yes, this time I will receive the post status 200. 200 means everything is all right. And then the body, which contains these random numbers. So we were able inside this lecture to make an HTTP request using the fetch method from Node.js, and we did it also for a get method, but also for a post method. Let's do the same inside a web browser in the next lecture. So let's see now how we can make HTTP requests inside the browser. For this, I've created a simple web page with two buttons. One button will invoke the get request, and the other button will invoke the post request. And the second button will read from an input type the number of numbers that we want. Let's see how this web page works. So this is the simple application that will read from our server. If I click get request, I will see the message. If I enter a number right here, I will get 67 random numbers, which will be printed to the web page. Maybe if I want two numbers, I will see them right here. And let's see how this happened. As I said, we are making a get request and a post request. And let me show you the code. Again, we are using the same URL, the URL of our server, and of course the server is running. First of all, the code is fairly similar to what we saw in the Node client code. The only difference is that we are also creating some HTTP documents in order to see the response inside the browser. Basically, that's the only difference. The same right here. First of all, we need the input numbers, and we are getting it from the document. Very important, a very important point, we need to somehow transform the input from a string to a number. Otherwise, the fetch request won't work. So make sure that whatever you are putting right here is a number. And this is the same point. In the end, I'm simply creating HTML paragraphs for each number that we receive from the server. Let's now talk about the async await syntax in JavaScript. And to understand it, let's start with a basic piece of code. Let's look at the two types of calls that we can make inside JavaScript. First of all, we have a simple code. Let's take, for example, this line of code in which we are simply creating a constant from a number that will simply transform a string to a number. A very basic operation which will happen almost instantly. On the other hand, let's look at the other operation, the next lines, in which we are making a fetch request. So we are requesting from somewhere on the internet, from a URL, from a server somewhere inside this world, some data. Of course, this piece of information won't come instantly. It will take at least some milliseconds. And with these two examples, we have come to the conclusion that we have two types of operations in JavaScript. Operations that are really fast, almost instant, and operations that take at least some time. Like for example, getting some data over the internet, or reading some data from a file, or writing to a file, or reading data from a database, and so on. Well, to understand this better and to understand why we need this await async syntax, let's see some examples. And let's start with a very basic example. Let's say we have the objective in this lecture to print the username and the salary of an employee. We have a company and we want to simply print the name and the salary of an employee. If I will execute this code, let's see if it is working. If I execute this code, I can see fairly simple that I get the name, I have the salary, and I can print it. Fair enough. But most of the time in real life, important data won't just appear magically into our code. We will somehow have to get it from maybe from the internet or from a database or so on. So let's see another example. A second example in which we are, let's say, simulating a longer call that we have to take. And in JavaScript, when we have a long time operation, we usually use promises. And if you want to understand promises, you simply have to think about when you are at a restaurant and you ask the waiter for some beverage or some food. Well, he won't bring them to them instantly, but you asked him, and now you have a promise that sometime in the future, you will receive your beverage or your food. The same with a promise. We are making a promise, and we have a promise that somewhere in the future, we will receive our data. In our case, I'm simulating that we are getting the salary of a user, and I'm simulating that we will receive the response only after 1 second into the future. The same with the name. Let's say we are maybe getting this information from the internet and it takes 1 second for us to receive the response. And now let's see how we can use it. Let's say we have a user ID of 5 and we want simply to get the name and get the salary and then print them to the console. Let's see what happens and pay attention to this code because it is very interesting. So if I will invoke this code, you'll see we are making the request to get the name, the salary. Then we are making the console log that someone has the salary of something, and only after we make the console log, exactly 1 second after, we in the end receive the name and the salary. So the problem with this implementation is that JavaScript simply proceeded with the code implementation, so it didn't wait, JavaScript didn't waited for the response or for the operation result in order for it to print them to the console. So even if these three lines are laid down one after another, the execution of JavaScript will simply proceed to this console log, and only after the console log is printed, because this happens instantly, after 1 second we will also receive our data, but at that point it is useless to us. So our mission is to simply somehow wait for the return of these two functions, and only then simply use the console log. We can do this by using callbacks inside JavaScript. So in this example, we have the exact same functions, but this time we are waiting for their result. For example, we are invoking the getName function, and if this function returns a promise, then we can invoke or use the then argument. And if I hover with my mouse over the then argument, you will see that it receives a onFulfilled callback. So this means that whatever this argument receives, it will be only executed once the promise is resolved. This means that this piece of code will be executed once we have a name. So this is what we want, because we want to print the name and the salary. But the point is that at this point we want to also know the salary. So again, we have to make a call for get the salary. We use the then argument. At this point we will also have the salary, and then finally we can make our console log. Let's see if this implementation works. So again, let me execute it. So we are getting the name, we are getting the salary, and in the end, yes, finally we see what we wanted. We see the name and then the salary in a nice print. However, this implementation has one major problem. It is really hard to read and to understand what is happening right here. And keep in mind that this is a very simple, trivial and dumb example. In a real-life code base, things will be much more complicated and much more hard to read and to understand what exactly is happening inside that code. For this reason, the newer versions of JavaScript introduced the Async Await syntax, and we can receive the same result but in a much better, easy to read way. So I have one final example in which I'm using this Async Await syntax, and in order to use the Async Await syntax, what we have to do, if we hover with our mouse over a function, we will see that this returns a promise. And if a function returns a promise, this means that we can use the await keyword in front of it. But as soon as I'm putting the await keyword right here, VS Code and JavaScript will scream at me, because it will tell us that await expressions are only allowed within async functions. This means that I need to convert this wrapper function, I need to convert it to an async function. Like this, and now the error will simply go away. And if this is an async function, then I can also use the await keyword inside it. Alright, let me save this example, and now let's see if our code is working. Again, this final piece of code. Yes, this final piece of code is working. We see the nice print, and our code execution is working just fine. When you will see this await keyword in front of a function, what the JavaScript executable will understand? Well, it will understand that it won't proceed to the next line of code execution. It will only proceed once it has a result to this call. So simply the execution of the program simply pauses until we receive a response for our call. And this is the reason we can make all this nice clear code right here. An important source of problems can be when you simply forget to put the await inside your calls, because there's no warning, nor no compilation errors, no nothing. But you simply forget to put your await and your program simply starts to behave strangely. In our case, we can see this strange print. We don't know exactly what is happening. So when you start to use the async await syntax, make sure that you use the await where you have to use it. And where you have to use it, you have to use it when you are invoking a function that returns a promise. If you use VS Code, that's fairly simple because you can hover with your mouse over the function and see that it returns a promise. In this case, you can put an await in front of it. Let's now talk about modules in JavaScript. And what are modules? Well, in a small convention, we can say that a module is a file that contains code that is available in other places. And most code bases are like this. If you want to build a more serious project, you won't put all your code into one file. You will have to break it into multiple files for it to be easier to read and to maintain. And in this lecture, let's see how we can achieve this objective in JavaScript. And in JavaScript, there are two ways of sharing, or there are two ways of making modules. We have the common JS modules, or the require syntax, and we have then ES modules, or the import syntax. And let's see both of them right now. So I have a new folder inside the references of this project. Let me create a new folder first right here, and I will say this common. And let's see how we can use common modules inside JavaScript. Let me create a new code file. I will call this math.js, and let me put right here a small dump function. For example, a add function that will simply return the sum of two numbers. Now our objective is to make this function available in other places inside our code base. And we can do this with the function module. Okay, VS Code don't even let me write it. Module exports. And then we can say that we are, from this file, we are making it a module. And from the exports field, we are adding this add function. And at this point, we are able to use this add function in other places inside our code. And let's use it. So I will create a new file that will use our function. Let me call this test.js. And right here, we have first of all, the objective to import or to somehow make a reference to this add function from the other file. And one way we can do this is by creating a constant, and we now need to use the require function. And very important, this is a built-in function, but only inside Node.js. So this common JS modules, this is like an old implementation of reusing code and modules, and it is only available inside Node.js. So right here, I will simply make a reference to our math.js function file. I can omit the file extension, but to make sure, let me just leave it like this. And now, even VS Code knows that now this is a function called add, and we are available to simply use it. So here I'll say const result is add, and let's just add two numbers right here, and let me print this to the console to see if everything is alright. We are able to run this code, but as I said, this require syntax is only available in Node.js. If we would try to run this inside a browser, the browser would tell us, hey, I don't know what require function you are talking about. But let's see if this initial example works. So I will execute this node. And yes, we are able, using the require syntax, to simply reference one code file into another code file. This is, as I said, the old implementation, or let's say the uglier implementation. There's another way in which we can achieve the same objective in a more easy to read way, and that is the ESM, or the import syntax. Let me create a new folder, and I will call this ESM, and again I will simply copy and paste these two files. The main difference right here inside the math function, if we want to simply make a function or a constant available outside this file, we can simply export it like this. And now this add function will be available in other places. And inside the test function, the test file, again, even VS Code will prompt us to tell us, hey, you can use the ES module syntax. You don't have to use the common JS module because we don't do this anymore in JavaScript. So I will click Quick Fix and I will convert this to an ES module. And now I will have this import syntax. This simply is wrong. I don't like it. Usually when I'm importing something from other places inside my code, I use this parenthesis mode. And right here, inside this parenthesis, if I press Ctrl space, I will see all the options which I can import from this my.js. Currently, only this add function. So this is the proper way to use the import syntax if you don't want nasty or misleading errors. Let's see if this also works. So I will invoke this code, and things are a little strange right here, but they are working. We can see the output of our code. So the result, we can see it is 3, but we are getting a warning from Node.js. It will tell us, hey, this is an ES module, but I wasn't informed that you want to run a ES module. In the next lecture, we will talk about npm and npm packages, and we will see how we can add this type module to our package.json file. Currently, we don't have this, so there's no way for us to tell Node that we are trying to run a module, but the important point is that this approach is working, and this is the modern approach to reference things around inside JavaScript. This approach will also work in the browser. So if I will create right here a new file, and I will call this index.html, again, I will use an emmet abbreviation for a sample file. We have the option right here to create a script, and the source of this script should be our test.js. Let's see if this will work. We will have some adventures making this work also. So if I will open this file and I will inspect it, looking at the console, you will see a already classical JavaScript error. Uncode syntax error, cannot use import statement outside a module. So again, the browser doesn't know that we want to use this import syntax and we want our files to be modules. For this, we also need, first of all, to make this script a module. So I will add this a type, and the type of this script will be a module. Let me save this. And if we go back again to the browser and rerun this, we will see another error. We will see something like a course error, but this is caused because we are launching this JavaScript file from a static point of view. We are simply opening this HTML file, and the HTML file is not served under a server. In order to get around this error, we first of all have to somehow serve this web page from a web server and not from a static HTML. If you want to do this, you simply have to launch it to install a server. One option to do this would be to simply install an extension inside VS Code. And if I will search for live server, this is the one. I will install this. And since this is installed, we have a new button on the top, on the bottom right, go live. But in order to go live, we have to open this file, this folder directly inside VS Code. For this, I will open it directly. So I will open this folder, only this folder, this ESM folder. And this folder now has this index.html at the top level. And now, if I will go live, we will see the same thing because now our file will live inside a server. And if I inspect this and see the console, we see this tree output of our test.js. We see this generic error about the favicon loading, but there's nothing wrong with this. The important point is that we were able to reference JavaScript files around. In this lecture, we will learn about npm, a package manager for Node projects. And in this lecture, you will see how you can basically start to work with it and why we need a package manager. If we think about it, there is already a lot of code written out there, public code, and we don't always have to reinvent everything that is already built and built very good. So we need a solution to somehow import existing code and do this in a secure and simple way. This is basically the mission of a package manager, and in my opinion, knowing how a package manager works for a certain language is just as important as knowing the language features. So this is an important lecture because no matter what you will do with JavaScript, if it will be a serious task and not just a hello world example, you will have to work with npm or other JavaScript package managers. npm is the most popular one, and it already comes installed with Node. So if you have NodeJs installed, you should already have npm installed. Inside a terminal, inside your computer, if you call for npm ---- version, you should see something. And let's now create, first of all, a npm project. I will work inside this folder, 12 npm. And right here, if we want to create a npm folder, we need to call npm init, this command, this npm init. First of all, this is a simple utility command inside the command line interface. It will ask us for a package name, and it will by default take the name of its enclosing folder, but I can give it any name I like for example, cool project, like this. I need to specify a version, and I will just click on enter until the file is created. And basically what this did, it simply created a package.json file, and this is a very important file in any npm project. If I open this file, you can edit it at any time, and it has some entries. We currently have no dependencies, and we don't have a dependency entry, but let's install our very first dependency, and I will install a small dependency to make a point. So I will clear this terminal, and inside this project, make sure that your terminal is inside this 12 npm project or where your package.json file is. We can call npm install, or I can even call npm I, and npm will know that I want to call npm install, and then the name of the package. And how can you search for name of the packages? If you go to a browser, there's a npm.js.com browser, and right here you can search for any packages you like. For example, I want to search for a package that generates random IDs. A very popular one is called UUID. This is the one. If I search it right here, you'll see this is the package main page inside npm. Lower down the line, I will see a link to GitHub page. I will see its how I can use it, some extracts from its README file. I can see how many weekly downloads it gets. Currently, it's like 161 million, so pretty popular package. Let's install it. And we can install it with npm install UUID. So right here, I call npm install UUID. And whenever you will install a package, be very careful about the package name you put inside the npm install command. If you have like a typo right here, this most likely will be like malicious packages, and make sure you don't want to install a malicious package. So when you install a package, be extra careful about the package name. I will click on enter, and now certain things will happen. Let's start with the package.json file. If I will open this file again, I will have a new entry inside this file, a dependencies entry. And I can see this UUID is now a dependency of my project. I will also have a package.lock.json file. This is a generated file which will somehow retain the state of my dependencies at this exact moment. This file will be regenerated every time I will call npm install. And we will also have a new entry called node modules, which for the moment will contain only our UUID package, and this bin entry which contains some executable files or packages from your dependencies. Currently I have this UUID package, and if we look back at the page from npm.js, you will see that this UUID package has 0 dependencies. But most packages will have a lot of dependencies. If, for example, I will search for Jest, which is a popular JavaScript testing library, you will see this one has 4 dependencies. And if, for example, I will install npm install and then I want to install Jest. Alright, and it took a while, and I see this message from npm. It added 322 packages. So not only Jest, but Jest with its own dependencies, and those dependencies with their own dependencies, and so on, so on. You will also see, if you are using source control, I'm currently using source control, that I have a lot of changes in my source control, and those changes come from this node modules folder. Very important, inside a npm project you should also have a .gitignore file, and you should add your node modules to the gitignore file, otherwise your source control will be overwhelmed. Very important, add the node modules to the gitignore file, because every time you will open your project, you will be able to simply install your dependencies with npm install, like this. But now let's look at our dependencies and let's use them. So I will create a new code file. I will put it inside a source directory. This is basically a good practice. And I will call this main.js. And let's now use our dependencies. I will call import from, and now I have a lot of options which I can use, options based on our dependencies. I want to use this UUID dependency. And right here, if I press Ctrl space, I see all the packages or the functions that this UUID package supports. I will use this v4 version. And now let me write my code. I will put it inside the main function. So I'll call this main function main. And this function main, let me invoke this v4. So here I'll say const random id is this v4 as a function. And then let's just print it. So here I'll say console log our random id. Alright, and let's now also invoke this main function downstairs, and let's run our program. We can run our program with Node.js. So here I'll say node and then src / our main.js. And we have a error that we already saw in the previous lecture. Cannot use import statement outside a module, because if we look at the package.json file, by default it will tell the node executable that the type of this package of this project is common.js. Let's make this a module. We are using modules. This is the modern way to do it. And let's try one more time. Yes, and this time we see the random string. However, we also have another entry inside the package.json file, the scripts entry. And right here, maybe we want to run we can add a script that will run our project. And let me call this dev, like this. We are simply developing at this point. And right here inside the dev entry, we can invoke our program. So here I'll say node and then on src / main.js. And this is a more clean way to run our program. If at this point I will call npm run and then dev, it will simply execute this command, which in real life can be a lot longer or complicated, or it can contain some parameters and so on. I can run my project like this, And keep in mind that even if you want to build applications for the browser, you want to build web applications, you will still most likely use npm to handle the dependencies of your project. As I said, npm is a very complex topic, but it's very important for you to know to work with it at least at a basic level. If you want to learn more about it, I have a dedicated video tutorial on my YouTube channel. You can check the link in the description. So, what is TypeScript? In a few words, it is a superset of JavaScript. So, on top of JavaScript, we have some more features. The main feature of TypeScript are the types, which describe the shape of objects. And this was a feature long missing in JavaScript, and it is the reason for TypeScript to exist. Well, before TypeScript or without TypeScript, you can at any time you can have all kinds of errors with this uncaught type error, because at runtime you might want to access fields of objects that don't exist, and this will mean nasty errors that you can catch up very early using TypeScript. And with these types you can give like a strong type to your objects and to prevent these very nasty errors, which can be really expensive in production. Other features of TypeScript are classes or enhanced support for classes, because JavaScript also has classes. We have also interfaces, we have decorators, and many more. We also have a compiler. This means that we can write code with the very latest JavaScript features like modules, like decorators, and so on, and we can transpile it for older runtimes if we want to support older browsers, for example. And following the course, we will get into all these TypeScript features. We will start with its installation, and if you want to make things easier for you, you can use the GitHub divs or the section resources. This being said, let's proceed into the next lecture and install TypeScript. So it's time to install TypeScript, and we have a lot of ways in which we can install it in order to use it to compile and then run TypeScript code. We have the option to install it locally as a dependency to our npm project, or we can install it globally as a global dependency, so anytime inside our system we will be able to invoke it. Let's do this. So inside the terminal, inside your computer, you should call npm. I will call sudo because I'm on Linux. I will call npm install -global and then TypeScript. I will click on enter because we want to learn TypeScript, and now this will install the TypeScript compiler, not the language itself, but the TypeScript compiler, which you can invoke with the command tsc. I will check this. So the TSC version is currently 5.9.2. This is the version at the moment I'm recording this lecture. And now let's create a simple program. I will create a new file and I will call this hello.ts this time, not .js, but .ts. And let's create a simple dump example first of all. I will create a constant. I will call this message, and now I will use a type annotation, the main feature of TypeScript, and I will say that this is hello. Let's simply print this to the console, and this is our very first TypeScript program. Now we have a lot of ways in which we can execute this program. First of all, let's take the most straightforward way, and that is we need to invoke the TypeScript compiler in order to transform this code from TypeScript to JavaScript. For this, we can simply invoke the TypeScript compiler tsc and then the hello.ts file. I will invoke this. I need to pass the right path to our file. And what this will do, it will simply create a new JavaScript file with the same functionality but without the types. So this is in one way, a way in which we can execute TypeScript code. Now we have a JavaScript code and we can simply invoke it with node and then hello.js, like this. This is one way in which we can execute TypeScript code. Another way, a more convenient way in my opinion, let me delete this JavaScript file. A more convenient way would be to install a program that will do the steps that we did right now, the two steps, the compilation and the execution, will do them in one go. And that program is called TSX. Let me show it to you in the browser. So if you Google for TypeScript TSX, you will end up in the TypeScript execute main file. And let's also install this as a global dependency. So on my computer, inside the terminal, I will call npm with sudo because I'm on Linux, install as a global dependency tsx. Before tsx, we had another program called ts-node, which did the exact same thing, but in the last versions of Node.js, it doesn't work properly because it is abandoned. Now we have tsx installed as a global dependency, and what I can do, I can simply invoke tsx and then the path to my TypeScript file. And it will simply work just like this. Let's now talk a little about the TypeScript compiler and basically how you can edit the way the JavaScript file is generated or the JavaScript code is generated from your TypeScript code. You can create a new configuration file with the option tsc --init. And what this will do inside your project, if you need to run this inside your project, and this will create a TypeScript configuration file. And the first time you look at this file, things can be a little overwhelming, for example, but with time, with editing this file more and more, you will understand better how the TypeScript compiler works. One of the most important entries inside this configuration file is the target entry. Currently, if you delete this, and if I control space right here, it will tell us, VS Code will tell us that ES3 is the default value. This is very wrong. That's not true. I think ES5 or ES6 are the default values, but choosing different entries inside this target will directly modify the way your code is generated. I think the ES next is a solid approach because we want to have our code as up to date as possible. Let's now talk about the main TypeScript feature, and we are talking about type aliases, or simply put, types. And their purpose is to define the shape of an object. The problem that JavaScript had for a long time now is solved with these type aliases. And how do they look? We can declare them with the keyword type, and let's say we have a type for a colleague. For example, we are in a company and we want to have a type for a colleague. We declare them like we would declare a constant in our code, just like this. So this is the type colleague, and now we can enter different fields for this colleague. Maybe this colleague has a name, and the name can be of type any, primary type or any TypeScript type. So this name, let's say that it is a string. This colleague can have an age, and this age can be a number, and maybe this colleague can have a position field, which can be also of type string. Now, when we will declare a constant or a variable with this type, I can say right here const my colleague. I will give it a type annotation of type colleague, and I will start to build this object. I will now have a compilation error until this object will satisfy the type definition. So even if I will hover over the VS Code error, VS Code will highlight this error. You will see that this type, currently which is an empty object, requires these properties: name, age, and position. And I will see this compilation error when I will try to execute or to compile this code. If, for example, I will try to compile this code right now, so here I'll say TSC and I will put it in src and these types, I will get a compilation error, the same compilation error that is highlighted beforehand by VS Code. So VS Code has a very cool feature in which it calls a lightweight TypeScript compiler on demand. You know, here we are manually calling the TypeScript compiler and we are getting a compilation error, but VS Code does this, as I said, a lightweight compiler mostly for type definitions on the background. This is the reason we have this very cool syntax highlighting to inform us that there's something wrong with our object. Now we can simply try to put some properties right here, and I'm usually inside an object, I'm triggering IntelliSense with control space. And now I can see what I can put inside my object. Let's give it a name, let's give it a age, and let's give it a position. Position, let's say that it is a programmer. Great. So these are basically the type aliases. Also, TypeScript supports something called union types, in which we combine different types together. For example, I can have a type called string or number, which is, for example, string or number, like this. And now any constant that will be assigned this type can be of type string or number. You know, this is pretty basic, but what is not so basic, a very good application of these union types are the string union types. For example, we can have a type called position that can be either programmer, or inside our company we accept HR as a position. And now we can specify that this position can be of type position, not string. We can use now this position right here. And the very cool thing about this is now that if I will have a typo right here, I will get a compilation error, and I will the TypeScript compiler will tell me, hey, you have a property position, but you don't have it right here. Basically, this is a great protection against typos when you want strong types in your code right here. Also, when you are building this with VS Code IntelliSense will directly give you the options that you have. In our case, we can use a programmer. And also, talking about fields, we can also have optional fields. If, for example, now I can make different fields optional with the question mark, and now if I will hover over this entry position can be of either position or undefined. This means that I can omit this entry inside my type, inside my constant definition. Let's add a new entry right here. Let's make this position as it is, and let's add a new entry called greetBack, which is of type function. Alright, and now let's make this greetBack optional, and let's say we have a colleague, and let's build another colleague, and I will say right here my other colleague, and let's give it a name, and also let's give it a greetBack function. And there's a very straightforward way in which we can declare functions in JavaScript, just like this, an anonymous function with a very simple implementation. Let's just add right here console log hello. And let's now build a very simple function. I will call this function greetColleague, function greetColleague, and this function will receive an argument of type colleague. So here I'll say colleague of type colleague. And now inside the body of this function, we will know that the argument will be of type colleague, and this is very important. For example, I can say right here console log, and I can say hi, and then I can append the colleague name. Again, if I'm not careful and I have a typo, TypeScript will directly tell me what's the problem beforehand. That's great, but also we can move on, and if I will say right here, I will put an if we have a colleague greetBack, and this is again a very important TypeScript feature. If this greetBack property can be either a function or an undefined entry, because it can exist or not in the type definition. Inside this if, we are making a truthfully check. So this greetBack can be a function or undefined. This is what the greetBack entry is right here. But inside the if check block, where we are making this check, the greetBack function will be defined. Let's see, I can say right here colleague greetBack. and I can make sure that this is defined. If I will say right here, you will see that even if this property is optional, inside the if block where we made the check, this type is function, not undefined or function. And let's call this function on the two colleagues and see what we get. So I will say right here, greet colleague my colleague, and also let's call the other one, greet colleague my other colleague. And let's run this. I will directly run it with tsnode. I have globally installed it, and as you can see here we are getting the greet for John and the greet back from Bill. That's great. Now we will talk about two special types called any and unknown. And the any lets us to completely disable the type check. For example, if I will have a variable called query result, and we don't know exactly what will receive in this variable, I can say that this is 5. And now currently, the type of this query result will be number. But if I will add a type annotation right here with any, now the type of this query result will be any, and I will be able to assign it to any other value. And I will be able to do this only as long as this is declared as let. So now I can say that query result is 5 as a string. And this is available, this is a JavaScript topic. If I will save this as a constant, now I will have a compilation error because I can't reassign this variable. But let's keep it a let to understand the types concerned right here. And now, if for example I can say that query result is maybe a string array, a number array, it doesn't really matter as long as any completely disables, I will write right here, disables the type check like this. And let's say that we have a function that returns a salary from an external service. I will write this function, and let's say that this function receives an employee ID, it looks on a database somewhere secure and returns us back a JSON parse. And I chose this JSON parse function, intrinsic function from JavaScript, is that it returns any. Since this parse function receives a text of type string and it doesn't know exactly what it will find in that text string, it will return us any. Well, since this function is returning any, then also this function is still returning any. Well, there's a much better way to handle these cases in which we don't know exactly what we are receiving inside our code, what we are receiving from an external service, be it an API, be it a function call, and so on. We can use, instead of writing right here any, because we don't know exactly what we will use, we can say unknown. If we don't know what we will receive, we can simply use an unknown. And why is this very important? Let me remove this unknown, and for example I can say right here, let salary is get salary from external service. I will put a 5 right here. I can say right here salary, and I can use the plus operator for this even if I don't know exactly if this is a number. And this is just a simply asking for trouble. This is a bug happening, waiting to happen. This is a very bad practice. What I can say right here is I can say that this function returns unknown. So I don't know what I will receive. I will have to check once I will receive it. And this type definition of unknown will force me to make further type checks. Currently, I will say that it will tell me, hey, salary is of type unknown, so you can't use this operation on it. You need to make sure that this is a number, and then you can make this operation on it. And how we can say this? I will simply make a check if, and we will use the type of operator that we talked 2 lectures before, and if the type of this salary is number, then inside this if check, then this will work, because right here this type will be number. This is called type narrowing, a very important technique. Again, we can make further checks. If for example I can say that this make the check, maybe this is a string. And now I can maybe I can make a check, maybe salary I can call string functions, like for example includes. I want to see if this salary includes the $sign. You know, I can call string operations right here because now I know that this is of type string. And I can also maybe make further checks. If, for example, I can say right here type of salary is string or type of salary is number, then I can only call the JavaScript functions common to string and to number inside this. For example, these are the three variables, these are the three functions that are existing for both numbers and strings inside JavaScript. And let's see an interesting example, and I will pause the video and write it. We have an argument of type salary, which is unknown at this point. Let's say that we want to make sure that we want to check if this salary is of type array. How we can make this check? Where there are lots of points we can do right here. First of all, we need to check if this type of salary is object. And then we can say that we want to store, let's say we want a salary history array. Let's say that our object has a history and we want to track down the evolution of a salary of an employee. We want to see if this has a field called history. So this is the way we can check for fields inside TypeScript, and also we want to make sure that this history entry is of type array, and we can do this with the array function from JavaScript. At this point, this history will be an array, and at this point we are able to push elements to it. So we saw in this lecture how the any objects, any types and unknown types work in TypeScript. The question is if any disables the type check, why does it exist, and why don't we only have unknown, since using it is a much better practice? Well, there are points in which we can use any. Maybe when we want to start the migration of a JavaScript project to a TypeScript project. You know, we have a code base and we want to introduce TypeScript inside a JavaScript project. We can start by annotating everything with any and then slowly deleting those annotations. So start of JS to TS migrations. Also, maybe sometimes we can use this inside unit tests. Again, right here, this is a accepted practice, since unit tests already make all kind of checks. There's their purpose. If we use any, then we assume that we know what we are doing. And also from time to time, you'll see this in code bases, but be very careful when you use it. Make sure that you limit the use of any. Functions are the place where we will use mostly TypeScript. And what I mean by that, you have currently the privilege to look at the dumbest function ever, and besides that it also has a compilation error. Well, we have a function which receives an argument and returns hello plus that argument. Currently we have a compilation error that tells that parameter name has implicitly any type. Well, because we didn't specify here any type, well, it says TypeScript understands that this is of type any, and currently our compiler options don't allow us to have this implicit any. If we will go to our TypeScript configuration, our tsconfig.json, and I will allow this no implicit any, I will make this false and save this, you will see that now we won't have a compilation error, but still VS Code will again give us a warning telling us that this name has an any type. Well, let's switch back to this no implicit any to true, and let's give this argument a value. Let's make this a string. And what is important about this function? As you can see, all the functions have some types inside their signature, what their parameters are, and also all the functions have a return type. In our case, our functions returns a string even if we didn't specify it ourselves, because here we are returning a string concatenation, then it will for sure return string. We can directly specify this by calling this string again, but this is somewhat redundant, especially for very simple values. If you have more complicated return types that it is important for you to specify them. If we are working with primitives in our case, maybe we can just let TypeScript infer the return type of this function. Well, if we will call this function, you can see that this John grid constant has now type string because it infers it from the return type of our function. Well, we also can have multiple ways in which we can handle our arguments. For example, if we know that our function argument is of type string, then inside our function body, we will be able to call different string options or different string methods right here. Maybe call the uppercase hello grid. Also, JavaScript has an interesting feature called optional parameters. For example, here we have this console grid John function, and what is interesting about this function, if I hover over it, you will see that now its argument will be of type string, but you will see that this has an optional modifier. This question mark indicates that the parameter to this function is optional. And why is that? Because if it will be missing, it will be directly have like a default built-in value. So we can call this function, I can say right here, console grid John without any parameters, or I can call here console grid John with maybe other parameters, you know, something like this. And this way, because at this point this parameter to this function is optional and it has a default value. And inside the function, notice inside the function declaration right here, this parameter is of name question mark, but inside the function body, this parameter is of type string. You know, we are sure that this is of type string and it is not missing from our function. Later on, we can observe a different way in which we can write our functions, and this is of course a little strange if you are used to other programming languages like Java or C#. This looks a little strange, but no problem. This is exactly the same thing as we did before. This is just a different way in which we can declare a function, you know, with an this is called an arrow function because of this sign right here. This is exactly like the other ways, but we are declaring it in a different way. And the last point which I want to emphasize is by having multiple parameters to our function. For example, right here we have a function called grid multiple, and this grid multiple function, as you can see, it can access a wide range of parameters. It can have 0 parameters, 1 or 2 or infinite parameters. And observe the type of these parameters. This is a string array, and this is called the spread operator, or the var arguments inside other programming languages. And this function can receive any number of arguments with the condition for them to be string. So we can call them by just one parameter or by 2 parameters or so on. Inside this function, what's important, these names are a string array. So of course we can call array methods inside it. Well, we saw in this lecture a quick way in which JavaScript and JavaScript functions work and are declared, and what TypeScript adds to the table, of course, cool types. The classes represent a different way of organizing code. So if we would talk about 2 important programming paradigms, we would talk about functional programming, in which we will execute or we will organize our code inside different functions, or we can have object-oriented programming, in which we will organize our code into objects or classes. And let's see how classes work inside TypeScript. I will create a new file and I will call this project.ts. And as a practice, usually we give the name of the class also represents the name of the file. So if I will have right here a file called project.ts, then as a good practice, but it's not really necessary, I can create a class project right here. And this is how we create classes. What can classes contain? They can contain three things. First of all, they can contain fields. And let's say these fields are simply the characteristics of this class. Let's say that a class has a name, and that name can be of type string and can have a budget. Our project can have a budget of type num. This is our simply put. These are our simply put fields. Now, also a class, very important, needs to have a constructor function, or simply put a constructor. And this is declared in TypeScript with simply the function constructor. And inside the constructor function, we can specify the function argument of type. Let's say that this constructor receives a function called, or an argument for name and a argument for budget. And to make the difference between the function argument and the class field, we usually use this syntax. So here we can say that this name is name, and also this budget is our budget. Since JavaScript doesn't support function overloading, we can't have multiple constructors. Maybe I want to have a new constructor with let's say a default budget. Maybe I don't want to have a budget argument right here, and this budget would be a default value like this. I can't do this in JavaScript and TypeScript, but JavaScript has optional fields inside functions. So for example, if I want to give a optional parameter for this budget, I can make it optional, let's say, and now I can simply make it like this. If we have an argument for budget, then we can assign it to our budget. Else, we can assign a default budget. I will say right here, this budget is a default budget, maybe like this. So this is the way in which we can have, let's say, multiple constructor functions, even if this is not correct, but this is how we can have multiple calls, let's say, for the same function. And we can try this downstairs. Here I can say const cool project is a new project in which I can give it a name, cool name, and I can give it a budget like this. I can also create another project. I can say right here const default project is a new project, but which will only receive the name like this. And this is the way we can have multiple constructor calls. And the last thing a class can have are methods or functions that belong to this class. For example, let's say we have I will say right here methods or functions. They are the same, but I won't specify them with the keyword function. I can directly give the name of the function. So I'll say right here print budget. Let's create a function that prints the budget, and simply put I can print the budget right. So this is what the class initially can do. Now I can simply invoke this method right here. I can say right here cool project, and I can access its field, or I can access its method like this. Let's move on into the next lecture and talk about access modifiers. In this lecture, we will learn about TypeScript interfaces, but in order to do this, we will break this lecture into smaller topics. First of all, we will learn about type extension or intersection. Then we will learn about TypeScript interfaces, which are fairly similar to types, but there are a few key differences. And then we will see when to use types and when to use interfaces. Let's get to work, and first of all, let's talk about type extension or intersection. And let's look at the example when we had two types, a simple job type and a complicated job type. And as you can see, for the complicated job, we have a fair share of duplicate code. Is there a way in which we can make rid or get rid of this code duplication? Of course there is, and that is type intersection. And let's look at another example, another piece of code I've prepared for this lecture. In this file, we have again a type of simple job and a type of complicated job. But this complicated job, what it does, it takes the simple job type and it adds some new things to it. For example, this complicated job at this point still has a coding language as string and the source control as string, but it also has some additional fields, like has many meetings and reports to be completed. The documentation says that this technique right here is called type intersection, but the mental model would be more or would look more like a type extension. And I guess the reason this is called type intersection inside the documentation is that if we would have the same key right here inside also this new type, then we would have any problem and it would just intersect the two. And if we have the same field right here and also the same field right here, of course the new type won't have two fields with the same name. That's not possible. I guess that's the reason this is called a type intersection. And as you can see, by combining or by extending this simple job type, we can get rid of code duplication and achieve the same functionality. Well, let's also talk about how these types and what their relationship is with TypeScript classes. Well, also in this file I've created a new type called meeting holder, which has two fields. First of all, a field with maximum length and a function which holds meetings. If you've worked with classes, maybe in JavaScript or in other programming languages like Java or C#, you know that classes can be programmed to interfaces or if types give the shape of an object, maybe the interface gives the shape to a class. We can take this mental model. And I've created this example to look side by side at types and interfaces in TypeScript. Well, classes in TypeScript can also implement types. You know, and if this class project manager implements this meeting holder, this means that for sure this class needs to have a field of maximum max length of type number, and of course he needs a method hold meetings. You know, this meeting holder shapes gives the shape to this project manager class. Let's now talk about interfaces, and let's talk about interfaces in comparison with types, because in TypeScript interfaces are fairly similar to types, but there are a few key differences. Well, I have created a new file which holds some interfaces, and as you can see they are fairly similar in the way that we can use interfaces just like we used types to give the shape or to match the shape of objects, you know, to describe the shape of objects. Just like we said on the left that we have a type simple job, we can do it on the right, we can have an interface to a job. The difference at the first glance is a syntactical one. Types are made just like we are declaring objects, you know, we are assigning objects. Interfaces are like we are declaring functions like this. You know, we don't have an equal sign right here. This is a difference, but this is just a syntactical difference. The functionality is exactly the same. Also, just as we did before, we can extend types. We can also extend interfaces, and also interfaces can extend types, but I don't want to get into that. So just as before, interfaces can extend other interfaces, take their functionality and also add something new to them. Again, we can use interfaces to give shapes to objects. You know, if we have typos or something like that, we should have compilation errors just like we did with types. Well, as you can see, they are fairly similar. And even interfaces can give the shape to classes. Well, we talked about the similarities between types and interfaces. Let's also talk about the differences between types and interfaces. And let's talk about a feature that interfaces have and types don't. For example, we have this meeting holder interface, which of course has this function holds meetings. Well, let's say that in our organization we have project managers which implement this meeting holder and they hold meetings. But let's say that inside our organization we have a problem project managers, some of them never end their meetings. So we have a small problem to this. Well, we can fix this problem and fix all the implementations of this meeting holder declaration by having a separate meeting holder interface. And instead of this holding meetings, let's just make this to just end meeting. And as you can see, this is not a compilation error. TypeScript allows us to have multiple interfaces with the exact same name. And as you can see at this point, our project manager class that implements our meeting holder has a compilation error because he also needs an end meeting declaration. So let me write this down right here. Alright, this technique is called interface declaration merging, and to be honest, in my opinion, this is a little misleading feature of TypeScript interface and maybe sometimes hard to read. This is just my personal opinion. Maybe you will have a great time using this TypeScript feature. Maybe if you are using an external library which has a declaration type and you want to also add something to that library, maybe like a REST client response, which you want to be unique across your workspace, then this declaration merging would be a great solution for you. Well, let's talk about other differences between types and interfaces. Well, we saw that interfaces also had this new feature, this declaration merging, and also maybe they have the advantage of having a more familiar syntax for developers that come from other languages like C# or Java, where we have interfaces. Also, something that types have and interfaces don't have is literal types. We saw previous inside this course that we can use literal types, maybe the most usual way in which we will use types. This is not possible with interfaces. And also another important feature that we will talk in the future lectures of this course is complex types. It's harder for us to have complex shapes for interfaces, but we can make very, very complex types in TypeScript. Well, we saw in this lecture what interfaces are and how they are compared to regular TypeScript types. The next feature of TypeScript that we will talk about are the generics, and in a few words, they are an extra layer of abstraction over types, functions, and classes. You can think of them as parameters for types. For example, if functions have arguments, we can also, for example, add arguments to types, and those types will be named generic types. And the question is, why do we need an extra layer of abstraction? Isn't our code already complicated enough with all the types? Well, generics will help us to reduce code duplication, to increase our code reusability, and also they will allow us to build stronger types. And they are crucial or essential for you to, if you want to understand TypeScript advanced types. And talking about generic tutorials, I have a full tutorial on my YouTube channel. You can check it out. Let's now try to understand the syntax of generics. The syntax is fairly simple. It's like this with two angle parentheses, and where T or any letter, let's say, or any list of letters, it doesn't really matter. They are a placeholder for a generic type. And let's say that we have a type called with items. So here I will say type with items, and these items are of type array. Well, maybe I want also a type with numbers, and these items will be a number array, or I want a type with strings, and so on. Well, I can build multiple types, or I can make this with items a generic type by adding it a generic argument like this. And now I have added a generic argument, and I can use this generic argument in the body of my type. And I can say that these items are of type T array. And now I can, for example, have a constant named with numbers, and this is of type with items, and this with items will contain numbers. And now I can give some arguments to this. And here these items now will be an array of numbers, maybe 1, 2, and 3. If, for example, I will add a string right here, I will have an error because string doesn't satisfy this generic constraint that we now put right here. If, for example, I can set this number to be number or string, then this error will go away. So we can complicate things a lot, let's say it like this. Also, we can add multiple arguments to our generics. I can have like this, and with a G, and maybe I can say right here more items, and this will be a G array. And maybe this with items holds numbers and string. And now I can have a new entry right here called more items, which will be an array of strings. So this is the basic syntax of generics, and this is the way we can use them. We saw this example with a type. Let's now talk a few moments about two very popular generics that most likely you have already used. You haven't used it before, for sure you will use them many times. And the first very popular generic type are the arrays. So if in TypeScript we can declare array as simple like this, we can say that this is a string array, but also we can define them as array and then with the containing type. And these two ways of declaring types for array are exactly the same. Let's now see how one example in which we will see how we can use generics inside functions. So I have created a very basic example of a function that uses the fetch API, the newly fetch API introduced also in Node.js. This fetch API, if you look at the documentation, it returns a promise of a response. Basically, with this fetch function, we will try to reach over the internet at the end at some URL and then get some data from it. And this result will be of type response. And you can also see one other example of a very popular generic is the promises. So this fetch function returns a promise of a response. And now if we put an await before the fetch calls, this result will be simply a response. If I somehow forget the await right here, then the result will be a promise of a response. In the following lectures, we will also talk in more details about asynchronous programming and async await syntax. But for the moment, let's focus on the generic types. The problem with this implementation is that since we are getting some data over the internet, we don't know exactly what we are receiving. This result.json function right here returns a promise of any, because we have no idea of what we might receive over the internet. But let's say that we know or we have an idea about what this service will return. Well, we can use generics in order to have some types, because currently this parsed result is of type any. Is there a way in which we can maybe add some types, because we are using TypeScript and we want to have some completion? Yes, there is, if we will use generics. And keep in mind, now I've made this function a generic function. This generic function receives an argument of type t, and we usually use this argument also as a return of this function. So this function, let's say that will return back a promise of t array, because this, let's say that we know for sure what service we will call, and then we will know exactly that we will be sure that we are receiving an array of t. And now this parsed result is still any, but when we will call this function downstairs, we will want to say that, hey, we are calling this function with an employee argument, and you can observe that this, even if we declared this function a generic function, this is not mandatory. We can call it downstairs without the type argument, and then it won't simply be used. But if I will add this employee right here, then the type of these employees will be employee array, and I will be able to access them just like this. So this is the basic way in which we can use generics inside functions to add some extra types for our type safety. And we can use generics also for classes. I will write an example and then explain it. So I created a class called memory database, which receives an argument of type t. And we can use this argument of type t everywhere inside this class implementation. We are working with an array of t, and now every time we will add a function, we have the option to add this t. The important thing is when we are declaring this function or this class. I've built this new memory database of type string or of argument string, and now every time we will call the add item generic function right here, we will be able to only call it with string arguments. If I'm not careful, I will call it maybe with a object or with an array, then I will get a compilation error. So this is also a way in which we can use generics inside classes. Well, generics are much more complex than a few minutes which I took in order to explain them. Again, I recommend you to watch my YouTube tutorial on this manner.